gonna do all the door prizes first? Door prizes are done. Oh, they're done. Oh, okay. Okay, so Ron Weinhold is going to speak to us today about glaciation of Minnesota. And I was peeking in this little box up here, and man, this is going to be interesting. We're going to find a lot of things here that I didn't even have any idea. We're around in Minnesota, so without anything further, Ron, come on up and give us a pitch.
Well, I'm going to be doing a lot of drawing on this little board. So anybody way in the back might want to move your chairs a little bit closer here. We're not in church today. And so anyway, if you can, it would be a good idea probably to get a little bit closer here.
Can everybody hear? Would you like them to use the microphone?
Can you hear me okay?
Yeah.
Okay, well,
I
I'll
got a couple people shaking their heads.
If you can't, move forward.
Well, if you can't, you wouldn't be able to answer the question anyway.
Right.
Okay, well anyway, we will get on with the program here then. And I've been interested in glaciation, and a lot of people come from all over the world to see our area. And a lot of you take for granted the little bumps and hills and rills that we have around here. And we'll give this a try. Is this better?
Yes.
Okay, great. And again, people come from all over to see our area, and we just take a lot of things for granted that they have always been here and so on. We talk about Ice Age. We are still in an Ice Age. We've been through a lot of glacial periods, but we are still in an Ice Age. Whether or not global warming is going to have anything to do with it is questionable, but glacial periods have come and gone. They say sometimes up to 13 or more glacial periods have been through our area. And we are especially interested in it because of the various rocks that we find in this area, specimens. And a lot of this is due to the glacial periods that have come through Minnesota and through the upper Midwest and of course through the United States. So when we talk about glacial periods, the last one, which we are probably the most interested in, lasted up until probably 9,000 to 11,000 years ago, and it lasted for 75,000 years. So that's quite a long period of time to think of our area covered with ice, and some of the ice was a couple miles thick. So it was quite a experience for our area to go through that. The glaciers, again, at one time they thought that they were all created by a lot of ice and snow up on the Hudson Bay, and slowly was pushed on down into our area. Now the thesis is that if we only were going a few degrees colder, that snowbank between your garage and your house wouldn't melt all the way next winter and next summer. So in other words, it would build up, another layer of snow would build over the top of it next year, and after that happened, again another layer after that, and the first thing you know, we would have a snowpack turning into an ice pack. If you pour batter into a pancake frying pan, you probably notice that when you pour the batter in the center, the edges of the pancake keeps on creeping out, the batter does. This was much of the way that glacier moved. Ice crystals would form in the cracks of the ice. These in turn would expand and cause the edges to keep on moving out. Now when we're talking about the last glacial period, that was the superior lobe, which came from northern Minnesota and also up into Canada. And I'll be doing some very crude maps of Minnesota here. And it came on down through the area, and it left a a terminal moraine from Hibbing all the way to the west of you here in Brainerd, went on down to St. John's and back through Minneapolis and back up through Wisconsin. And this is the one that brought our glorious agates from the North Shore and so on, and caused the terminal moraine was the final stages of that particular one. However, different glacial periods went all the way down into Nebraska. So sometimes the hillside that you may find agates in, and you go to the next hillside and it doesn't have any agates in, you wonder what's going on. But that is a good way of explaining the red drift and the gray drift. And we are usually in this particular area, of course, we're calling the red drift because of the iron ore in the rock. But with the United States here and Minnesota, the gray drift came down from the Dakota prairies and came into western Minnesota and left a series of moraines along, including Inspiration Peak and some of the areas over there. And as a result, the gray drift came up to the red drift. And the red drift is the one that had all of our agates and so on in. But the gray drift had a lot of limestone, a lot of fossils. If you go down by Sauk Center, the fields have petrified wood in them instead of agates. And so you're not that far away from the gray drift. And my land at Little Sauk has both the gray drift and the red drift on it, which is pretty unusual to have the combination of the rocks from northern Minnesota and the rocks from the Canadian provinces on the same piece of property. So that makes it a very, very unique situation. Gray drift usually has a lot of limestone in it. So if you're looking for agates and you see a lot of limestone in the soil or the gravel cuts and road cuts and so on, that's probably the gray drift instead of the red drift. And again, by bringing down rocks from the north, you got into the different, lot of irons, and you had the Ely greenstone, which is amongst the oldest rock in the world, and that's up by Ely, and it's actually fossilized algae from the bottom of the ocean, and it's green, and that's why they call it Ely greenstone. You'll be able to look at these specimens after a while, and I will just label them to show you what some of them are at a close-up look. With the glacier moving along, it did several things. It would use rocks like this, or huge boulders, and they would be polished or scratched on the bottom from being drug along over other rocks and cliffs and so on. So you'll be able to see some of the striations on some of the rocks, including some of the rocks that you find around here. Or you will find glacial polish up on the rocks around Lake Superior. When you come into Duluth, look at the road cuts there, and you'll see the tops of the rocks are actually polished off by the glacial action on it. A lot of times people find these perfectly round rocks and they automatically think they're an Indian artifact, but they're a glacial roller. In other words, they roll like a ball bearing and actually rounded themselves in the process of it. So you'll see a lot, off and on you'll find those, or you'll find other rounded rocks at the same time. Glacial polish, again, can be sometimes very simple on ordinary rocks. You can find that as well. And we do find a lot of iron in our red drift because of going over the iron mines of northern Minnesota. And you want to lift this beach because it's very, very heavy. It's probably almost pure iron. And it's, again, been eroded by the glacier, tumbled, rounded, and not jagged. Minnesota, again, when you get back to the iron mines, those were shallow seas at one time, and the iron oxides eventually leached out of the volcanic flows and filled these shallow oceans or waterbeds with rust, which was compacted and turned into our iron ore of today. So those were the original iron pits there on it. And as a result, you occasionally find the pyritized snail shells and clam shells and so on around the iron mines because they were water basins at one time. Different things were brought down by them, and if you're lucky enough, I don't know how many of you in the crowd have found native copper, but it's very possible to find native copper around here. And we do find specimens of it all the way down towards Long Prairie. This is just one little nugget of it. It can be found and it can weigh many, many pounds occasionally. The soil will be green around it if it's in suture. It is pure copper, and it was brought from either Isle Royale, Michigan Peninsula, or up in that area by the glaciers. So you can find this, and it's rarefied if you do, but you can find it as well. Something the glaciers did also, they made glacier flour, and this is a jar of it here, and it's about as fine as bread flour, and it was from the grinding of the rocks to get this flour material off of it. Down in southwestern Minnesota, the hills and the dales there are lowest, and they were drifted dunes of that particular glacier flour. And it's very rich soil down there because it actually blew as dust and blew into dune-like forms of it. Once again, the glaciers changed things drastically. When you start thinking of the weight of a mile or two of ice over the land, what a difference it would make. Lake Superior is a good example of the after effects of a glacier. Lake Superior is tilting. The North Shore is going up an inch every year, every 100 years, excuse me. And the South Shore is going down because all that rock was compressed with the ice, and now it's beginning to tilt the lake. So don't buy any land on the Wisconsin side. You may have your lot underwater there, but anyway, to think of that whole lake being tilted a little bit, an inch every 100 years. When you come into Duluth and you look down at the St. Lawrence River outlet, you know, that little snaky thing coming in there on above when you look at the Skyline Drive and look down at it. That was a rock canyon at one time. And the St. Louis River carved a canyon out of solid rock. But now the lake has tilted and flooded that canyon, so it's a canyon that's flooded on it. The rivers in Minnesota also changed drastically, and when you start thinking of the river system that we have in Minnesota, we have the Minnesota River snaking in and joining the Mississippi down here, the St. Croix River joining up down from Taylor's Falls in this area, and this is a lake here, and those are old fossil river channels. We have Lake Agassiz up here in Canada that went through part of Minnesota, a huge glacial lake at one time. When it drained, and eventually it drained down the Minnesota River Valley. And why we call it a fossil river channel, if you've been down to Granite Falls and Redwood Falls and some of the places, You look over a huge valley that's probably a mile across or more. That was level full of water at one time. And if you go down the Mississippi River, well, let's say the St. Croix River here first. You look across to above Taylor's Falls, that whole thing was level full of water at one time. That's when those big potholes were created and swirled around down at Taylor's Falls. So you can imagine the lake didn't have any exit out the St. Lawrence River. So all of this melted ice up here had to go down the St. Croix and another spot just before the St. Croix River to get and join the Mississippi River down here below. When you're on the Mississippi River, that too is a fossil river channel. And I know some or most all of you have been down to Red Wing, and you've seen Barn Bluff at the end of Main Street of Red Wing. It's a huge bluff, 300-400 feet high. There are bathtub rings on the very top of that bluff from how high the river was at one time. So it was 2 miles across or more, the Mississippi River. So the Mississippi River too is in a fossil river channel. But all that water had to go down from the melted ice as the glaciers melted on it. And again, it brought down the many different kinds of rocks and so on, and the process of it brought the copper and so on from the other areas, the gray drift. And that made a big difference there in the plant life as well as the animal life too, with the different glacial features that went on. Petrified wood, like I said, can be found over by Sauk Center, and that was from the fossil forests of Canada and up on the Great Plains as well. So you don't have to go way out west to find petrified wood. And so it too has the possibility of finding actually Montana agates, moss agates in western Minnesota. And this is a moss agate from western Minnesota rather than going way out on the Yellowstone River someplace to find them otherwise on it. The different forms of plant life had to make up for the difference also on the cooling of the area. And when you think of the United States, we have quite a unique thing growing for us here, and that is the fact that our mountain ranges go north and south. The Appalachian Mountains, Rocky Mountains, Cascades, Sierra Nevadas, and so on on the United States. And we were very fortunate to have these mountain ranges going north and south, because in Europe, the mountain ranges go east and west. And as a result, there was mass extinction of plants and trees because they couldn't keep ahead of the glaciers. They ran up into the mountains, the Alps, and they became extinct. Our plant life was able to go south during the glacial periods. The Great Smokies are one of the oldest Appalachians, one of the oldest ranges in the world. They were probably as high as the Himalayas at one time before they were worn down. So they actually were a much higher range at one time. And again, the extinction of these plants, what happened to the plants during the time of the glacial period? Up here in Minnesota, the maples went all the way down and spent 75,000 years down in New Orleans. And the pine trees went down to the bottom of the Great Smokies and spent 75,000 years down in the bottom of the Great Smokies. And they, just within the last 11 or so thousand years, have slowly made their way back up into our area. Minnesota, if you take and divide it into about 3 sections, there are about 3 times as many different kinds of wildflowers and trees in far southern Minnesota. Then you come up in our area and it's about 2/3, and you go further north and it's only 1/3. So these plants are still migrating up, like the silver maples are coming up the river systems, and the pine trees and so on are still coming up from the south from this glacial period. There's one little county in the Carolinas that has more varieties of trees and plants than all of Europe. And that's pretty amazing. Not one state, one county has more varieties of plants, trees, and grasses than all of Europe. So they have the sloping of the mountains there, a little bit warmer climate, and on up into the Appalachians, and they have the advantage of having that tremendous amount of plant life to do that. So how fortunate we were to have so much of our things protected. I forgot to say that in the desert Southwest, when the glaciers came down, there were many potholes and swamps and so on through the desert. So the giant vultures and so on had a lot of predation to have animal carcasses and so on. The temperature was warmer, so there were more redwoods and other trees in other parts of the United States, but they too had to move out on the edge of California here to survive. And so a lot of these things, the whooping cranes that we are trying to save are remnant from the little prairie potholes and so on that were real prevalent at that time. The glacial period again did a strange thing with the United States here, and that is it was very cold all the way down to Texas. The prairie states were all tundra at that time. So different things had to split. The bluebird family had to turn into the western bluebird and the eastern bluebird because of this cold tundra going on down. There were western meadowlarks, eastern meadowlarks, because of that particular time. Now we're doing a very strange thing. We have windbreaks going across the prairie, and as a result, some of the western birds are coming into our area. We don't call the white-breasted or slate-colored jonquil a slate-colored jonquil anymore, because they're breeding with the western jonquils. They're coming across the windbreaks, and so we just call them jonquils now on it because of that reason. So we in turn are kind of changing things as well. The animal life again, but we should probably just very quickly go back to just a few of the landforms to go back to the early glaciation here. And you're familiar, we talked about the terminal moraines, the final push of the glacier making the ridge of dirt. Cames are somewhat prevalent in the area. When you had the ground surface and a thickness of ice up here, if you had a manhole that came down through the ice, filled a cone-shaped hill like Inspiration Peak with dirt and refuse, that was called a came. And so that's a came, K-A-M-E. Then you had, like in between here and Little Falls, an esker, and that one is world famous. It's a serpentine, like rigid hills that goes along across the prairie out there, and it looks like a big snake. That's when underneath the glacier, a stream would flow, and it would fill that stream with dirt and sediment and gravel, and that was called an esker when it melted away, and it would look just like a snake, a type of thing. And of course you have the potholes with pieces of ice that were left over in and left the depressions in the ground. Our lakes, of course, were large stagnant pieces of ice that too were embedded in the glacial material, and when it melted away, it left those depressions. So those were how our lakes were formed. Drumlins happened at the front of the glacier, and they usually tell the direction that the glacier came from. They are long, elongated hills, sometimes in rows, and there are quite a number of these over towards Staples and southwest of Staples. That tells the direction of which way the glacier came. Cracks either filled up with sediment, and then when they melted away, they became long hills. Those are called drumlins. Glacial erratics are interesting also. You'll have huge boulders. Sometimes they will be probably a quarter the size of this room. And they were pushed by the glaciers also and left as the glacier melted, and those are called glacial erratics. So those are just some of the different forms. The loess, we were talking about the loess plains and our different materials from the glacier. One thing a lot of people don't know, and that is the fact that you can get stuck in sand, loose sand, much easier in the desert or along the oceans than you can in our sand around here. And the reason is, if you magnify the sand, you'll find it's like crushed ice. It has sharp edges. And as a result, the sand crystals lock together. But out in the desert and the ocean, they're like ball bearings. And so you're actually like in a marble pit, and your wheels are spinning because the gravel is not jagged like our gravel here in Minnesota. We are very lucky, again, to have this amount of gravel for our road construction. A lot of places they have to crush rock in order to build roads and highways and so on. We have unlimited gravel and sand from the glacier here in Minnesota, so that is a distinctive advantage. Now we've talked about the plant life moving various areas here during that time, but let's talk now about where the animals went. And some of the animals that actually were here, once again, with the United States, they were able to keep ahead of the ice, and some of them went way down into Mexico, Central America, and some of them managed to stay in the parts. The Gulf of Mexico, where we just had the hurricane, was very shallow at that time because of all of the ice had a lot of the water locked up. And so when you get down here at Fort Myers and some of the places along here in Florida, you can actually find mammoth bones, mammoth teeth, and different land animals that live way where the ocean is right now in Florida, just because of all the ice that was locked up in the glacial period there on it. Some animals went way down into Central America, and of course, after the glacier started retreating, then some of the animals had a bit of a heyday, and they were able to follow the glaciers back up again, like mammoths and some of the other animals. At one time we had camels around here. We had muskox, very much like up in northern Alaska. We had mammoths, mastodons, and some short-faced bear, a giant beaver, a ground sloth, a lot of different animals that are no longer here. And as a result, they have left some of their bones. We have found mammoth bones and so on in our area. One of the things that I find on my own land in the river is one of the fossil bison. And if you've been to my place, you remember the whole skeleton assembled. I also have a 9,000-year-old horse from my river too on it. Horses at one time went all the way from Alaska all the way to the tip of South America, and a disease came through about 9,000 years ago and killed all the horses in the New World. So it must have been a vicious, vicious disease. And now we have their bones found in the swamps of Florida, in the La Brea tar pits in California, at my place in Minnesota, and also occasionally gravel pit people will come up with fossil mammoth tusks, mastodon tusks. When well drillers are drilling for wells here in Minnesota, occasionally they will come through a layer of pure wood. And this piece of wood is from a forest that was buried up on Lake Michigan under 30-some feet of ground. And this piece of wood is 11,000 years old, and it's still wood. And there are little pine cones, little twigs, little arborvitae twigs, and so on in that layer along the lake shore that you can actually find, which is pretty unique. And to think that people are drilling wells here 200 feet deep and coming through cores of wood like this. And that happens also here in Minnesota as well. So again, the different animals that lived here. In my river, we wade up to our chest in water and feel in the bottom of the river. And I have enough bones to put several of these antique bison together. The bison antiquus had a much higher hump on its back than the bison of today. This is bison of today, but this is bison antiquus, and then there was another bison before that had straight horns on it as well. So you can see that it was quite a bit of a different type of a bison than we have of today, much larger and so on. Again, other animal things can be found like the horse bones I was just telling you about, and this is a jaw of one of these bison also from my river here, and you can see that as afterwards when we get up here as well. Then what happened, of course, we came along, and when you think of of mankind coming into our area here, we have the Alaska here and across Canada, Hudson Bay here, on out to the United States. We had this Minnesota, we better put Minnesota in here. We had Lake Agassiz up here in Canada, coming through Minnesota here up in the corner. But we had a tremendous amount of mountains here to contend with for, whoops, I'm going way above Alaska here. Mountain ranges in America here. And there was a land bridge across from Alaska. There's also a new theory that possibly some of the Indians or the natives came across from Europe and went across along the edges of the ice floe and came down into the United States that way. And that still has been in controversy so far. But for these Indians to come across, the natives, they would come down and probably come down the eastern edge of the Rockies, in some cases following Lake Agassiz along and coming through Minnesota and then forming the wonderful civilizations of Central America and Mexico. Just because of Lake Agassiz here, we may have had some of those migrations of people coming right through our area here in Minnesota. So then you had mankind get in here maybe as early as 30 to 40,000 years ago. And they left Folsom Point, some of the very early artifacts. If some of you are artifact collectors, you get into the Folsom and paleo people. Okay, well, they too may have helped for the extinction of some of these giant animals by, they were very stupid, a lot of the animals, and as a result, they were easy prey. And it's possible that we may have been part of the reason for their extinction, or the extinction is simply because of the changing of the land after the glacial periods on it. So what will happen now? We are talking about global warming all the time, whether or not that's going to have an effect on the next glacial period. But all it would take is just a few degrees difference. If you've been up in northern Minnesota in the end of June, the first part of July, and you take that sphagnum moss and peel it back, there's still frozen ground under it. And people put their fish on it and preserve it that way. So then you start going, at this time of the year, it's already beginning to freeze up. So you have a matter of just a month and a half that there isn't permafrost in some of the areas here in Minnesota, which is pretty wild when you think of that. Getting back to the sphagnum moss bogs just for a second, I'm regressing here a little bit. There's exactly 9 to 12 feet of peat in our peat bogs around here. And then there's pure gravel, or pure sand, pure glacial sand. So in other words, it takes 1 foot every 1,000 years to make peat. And if you break open one of your bales of peat for gardening, and you see little leaves and twigs in there, some of these are several thousand years old, which is a long, long period of time there. But anyway, just a few degrees difference, and we could be going into another glacial period. And chances are this is going to happen again. We had the little ice age from the year of 1200 to about almost 1900. Our settlers had to put up with a few degrees colder than what we have right now. And so it was changing already. It changed back, and now it depends on whether we have this warm period or whether we will be able to change that over. So, and of course, one volcanic eruption like Yellowstone could also turn us into another glacial period or another ice age as well. So those are things that are in delicate balance, and we will see what happens, and if we stick around for a few more thousand years, we'll be able to find out. So anyway, that's all I have. And are there any questions that you would like to know? Yes, move way back here.
You spoke of how the glacial hills were formed.
Yes.
And I was wondering if that's the same thing as a glacial moraine, or is that something different?
Glacial moraine is, again, the edge of the glacier, like a big bulldozer pushing it up. If you've been on Highway 27, just east of or west of Little Falls, you have that huge ridge that you're going over. We call it the Big Hill all the time. And there are recessional moraines before that. In other words, the glacier pushed like a big bulldozer and then hiccuped, went back, and made a little push. Those are recessional moraines, those little ridges. And so those are other forms of it. But the moraine is, the terminal moraine is the final edge of the glacier. Yes?
Why wasn't the driftless area of the Wisconsin glacier?
That's another thing that I forgot to mention, and I should have done that. Well, we'll do, get rid of this here. If you've been up to the Michigan Peninsula, and it's a beautiful area to go to, we'll do Wisconsin down here, like Michigan, and this is the driftless area down here. But if you get up to Michigan Peninsula, there's the Porcupine Mountains up here on the edge of Lake Superior, and that was quite a bump. And they think possibly the glacier split because of that bump of rock up there in the Porcupine Mountains, and left the bluffs and limestone cliffs down into southwestern Wisconsin and southeastern Minnesota. So that's their probability. That was a good question. Yes?
Continental divide, did that have any issues to do with the glacier?
The continental divide, again, when you start talking about it, the poles are not stable either. The whole world can tip, and of course the plates of the moving around like they know they do now. Probably the continental divide wouldn't have too much to do with it, but again, the glaciers have come and gone. You know, the glaciers in Glacier Park are almost all gone now. But all it would take again is a few degrees difference and they would start growing again. There's only one glacier up in Alaska that's actually growing. The rest of them are all departing because of the warmth. Any other questions? Yes?
Is there any glaciers in the southern hemisphere that come?
Yeah, well, you get down to Patagonia and down through there.
Did they go at the same time as ours? I mean, were all the animals being compressed in the center, or was it more?
Well, they have a reversal of seasons, of course, so,
Yeah.
but they too have had problems. As you know, Antarctica is melting quite rapidly right now too, and so whether or not this is just a warming period or whether it's something that we have to do with it, it's questionable. Yes? Mm-hmm.
Down in St. Cloud at their one park, Quarry Park.
Yes. Mm-hmm.
And there's a big area of rock about as big as in here, and you can see where the glaciers went across it.
Right, right.
Scraped across it.
That's a good observation. A lot of glacial scratches and glacial polish on some of the tops of it. Granite formed way under Earth. It was lava, but it never reached the surface. And had it reached the surface, it would have turned into just plain old gray basalt or gray rhyolite. But being as it cooled underground, it was able to make the little squares and cubes of feldspar. And but it hadn't reached the surface; it would have been that. So that's the difference. And again, when we talk about the park down there, that has one of Minnesota's 4 hardy cactuses on it. It has a little tiny cactus called fragilis. And there are 3 other hardy cactus in Minnesota. You can't imagine cactus coming through Minnesota, but it does. Okay, yes.
With that splitting of the glaciers there, does that help form what some call the Black Hammer Mountain Range in southeastern Minnesota?
It's possible, yes. Again, to have a reserve of rock that with many millions of years older than the rock that was destroyed all the way around it, you could probably have that case. Yes, right. Mm-hmm. Any other questions? Yes, way back there.
So what, how did the glaciers affect the caverns, especially down like in southeastern Minnesota? Is that where that river came in? You know, like the...
What? I didn't quite understand.
The caverns?
Oh, the caverns, the caves, you mean? Yeah. Well, they were knocked ground to pieces because of the limestone down there, and the glaciers didn't really destroy those areas. Had the glacier run over like Mystery Cave and some of those, they probably would have crushed those caverns in. But that area is driftless. That avoided that. And of course, limestone is many feet thick in those areas, which was actually sea bottom at one time. Okay, any other questions? Well, I must have covered it pretty well then. So anyway, thank you so much. It was fun.